In a previous video, I went over how to make lead acetate, and I did that primarily so that we could grow some lead crystals, and that's what this video is about. So our materials that we need is lead acetate, water, and a solid piece of zinc. Not big necessarily, maybe 3 inches long and a quarter, 3/8 inch wide would work. Zinc has a melting point of 787.2 degrees Fahrenheit, and it's not that much higher than lead. It's about 150 degrees higher than lead. So using a chunk of zinc or zinc from anything, you can melt it pretty easily with a torch. If you ever had zinc pennies, which are basically copper coated, and put some butane or propane torch on it, it will indeed melt the pennies very easily. Our methods: make our lead acetate solution. We need 10 grams of our lead acetate in 80 milliliters of distilled water. And just for note, anytime I say water on any of my videos, unless it's otherwise noted, it's always distilled water. Once you have your solution, you need to take your zinc rod and suspend it within the lead acetate solution, somewhat like this. Now, I'm not going to be using a tree, but something else to indeed keep this up here. You could even put a stick right across the top here and tie a string and then drop your zinc into the lead acetate solution. When you do that, lead crystals start to grow immediately. And basically that's because the reaction is as follows. You need zinc because it's being oxidized and it's giving up 2 electrons. And the lead is being reduced and it's gaining 2 electrons. So when it's in the lead acetate form, there is lead in there, but it's not lead metal. When it's reduced by gaining the 2 electrons from the zinc, it turns into lead metal, and it will start to stick to that zinc rod and start to grow these kind of feathery like crystals into the solution. And it takes some time, maybe an hour to actually start seeing them big enough, but they do start growing rather quickly. So it's a pretty windy day here in southeast Michigan, and I hope you can hear me okay above the torch also. But just to show you this, I'm going to melt some post 1983 pennies, which are zinc and basically copper coated. Well, there's a couple pennies that don't want to seem to completely melt, but see if I can do this without getting any of the dirty copper in here. Okay. Here we go. So this is the copper that's left here, most of it. Some of the pennies wouldn't quite melt, like 1 or 2 in there, but the rest of it is just the shells from the pennies. I melted another 50 pennies or so and just poured it on top of the last one. So this is about 80 pennies worth of zinc, but it's nice and one solid chunk. I just need to make it for sure now into some sort of a rod. I have my form that I'm going to pour the molten zinc into. I've used wood before to make like lead bullets by drilling a hole the right size, and it worked great. And I got this by using this, which was part of a old golf club, and I cut it and then dremeled out a piece and then just, like this. If you have carving tools, that would be great. I'm sure there's other ways to do it, but we're going to use that. Plus it carbonizes right away, which prevents any heat from getting deeper. I was thinking that, Canada got rid of all their pennies a couple years ago, but here in the US we haven't. They're pretty much worthless actually, but I'm glad, honestly, we haven't gotten rid of them yet. Okay, I waited a good hour because I burned myself doing this before accidentally, but oh, that came out of there real nice and easy. Look at that. So we have our bar or rod of zinc right here, all made from pennies. Very good. These are the final two pieces of zinc here. The rod you've seen. This is what I poured into the cupcake thing, the leftover zinc, and I'm just going to hold on to that for now. But this piece, as I looked at it, and I thought crystals like to grow off of edges or imperfections. So what I think I'm going to do is kind of sand off the ends here and put some corners on it, places where the crystals can initiate themselves. So I finished sanding one end here, and I realized that I don't need to do the other end because I'm going to hang it asymmetrically. So this end is in the lead acetate solution. I tied the zinc rod so that the squared end falls below the 80 milliliter mark, which we know will be the lead acetate solution, and it's just suspended up here like so. We just need to add the solution. Here's our 10 grams of lead acetate, which we made earlier. Starting to dissolve the lead acetate into the 80 milliliters of distilled water. All right. Wait till that spins, mixes well, and dissolves. All the lead acetate dissolved, and that solution is nice and clear. I pre-hung the zinc bar in there, and I am now going to pour the lead acetate solution in. You can already see it affecting the zinc rod and changing its color. You can already see the lead crystals growing. It's only been about a minute. Although there's lead crystals there, the growth has slowed down a lot, and I'm thinking I'm going to dunk the entire zinc rod into the solution. Okay, I put the whole thing in there now. You can see that ring there that was forming on the surface that's now in the solution. This is around 20 hours later, and we can clearly see the lead crystals drooping down just like they're supposed to. 24 hours later from the previous video, 44 hours total, and the lead crystals are growing really well. It's been 66 hours, and there is a jungle of lead crystals in there. Some of those have drooped down and touched the bottom of the beaker. This is 68 hours later. This is the backside of the beaker, and didn't get to see much of it because it was on the other side of the camera, the time-lapse camera. Look at those few crystals on the bottom there that are growing just like a sheet. Just to show some of the crystals more clearly, I'm going to shake this a bit. You can see them a little easier.